Hello everyone, welcome back to my channel. My name is Piyush and this is video number 11 in the series CK 2024. So till now we have covered a lot of fundamentals of Docker, Kubernetes. We have seen pods, deployment services and few other details. And in this video we'll be looking into multi-container pods and few other related concepts. So the comments and likes target of this video is as follows. I am expecting at least 120 comments and 280 likes in the next 24 hours. Please help me do that. And also, I don't see a lot of you sharing your learnings over social media platforms such as LinkedIn or Twitter. Please do that. Please help me spread the word so that others can also take the advantage of this learning opportunity. And yeah, and that's the only request that I have. Please support me with this, and I'll keep uploading the videos like this, and I'll make sure that I complete this series within the time frame that I have committed. All right, so thank you so much for your support till now, and with that being said, let's start with this video. Okay, so let's quickly see what exactly is multi-container pod, and then we'll move into the demo. So let's say you have a pod running on your Kubernetes cluster and it has one app container, which is, let's say, Nginx. So this is your app container. Okay. And now we can have additional containers to support this app container. These containers could be like, let's say we have a container over here, and these containers could be an init container, or initialization container that actually runs before the app container to do certain tasks, right? Or this could be a sidecar container. Sidecar container that runs all the time with the app container, and it provides certain input or it takes certain output from the app container. It is also referred to as an helper container, right? So you can have multiple containers with either of those. So let's say we have this additional container running, and let's say this is an init container. Okay, so what it will do, it will run certain tasks. So whenever kubelet sends the request to the to the pod for the initialization, that let's start the pod, it will first start the init container. So the first container that will be started is init. So as soon as the init container completes and it finishes its work, then only the app container will be started. So starting of app container is totally dependent on the init container, and it works according to the app container. So whenever app container restarts, stops, init container goes down with it. So it works in conjunction with the app container, and it shares the resources of the pod. So let's say we have allocated some memory, some CPU, some storage to the pod. So that resources, all those resources will be shared among all the containers inside that pod. Okay, now let's get into the demo and let's see how it works. Okay, so I am in my Visual Code editor. Let me full screen it, and I'm going to create a new file, and I'm going to call it pod.yaml. Okay, so let's start writing this file, and I will be explaining as I'm writing. So I'll start with API version for the pod, which is v1, and then we have kind, which is pod. Then we have metadata with the name and labels. I'm sure these are now kind of make sense because we have practiced it enough, and I'm sure you don't have to really look at the documentation to write these things, to write a basic manifest or to run the basic commands. If you're still facing that issue where you have to look the documentation again and you have to check out those links again, so make sure you practice more so that it will save some time in the exam. So let's give it a name, my app, okay, and give it the labels. Let's use the same thing, my app pod. Okay, now the main part is spec. Inside spec, as we have seen earlier, we have a list of containers. So our first container will give this a name and we'll call it my app container. Okay, and then we'll use an image of busybox. This is basically a generic image provided by Kubernetes and maintained by the community, and it does a few basic tasks for you, and we'll see like in the later videos as well, we'll be using it more oftenly. Till here we are good. Till here, this is what we have done earlier as well. Now let's see the concept of how we can use the environment variables inside the Kubernetes, right? So this is our manifest. Inside container, we have name, image, we can expose ports as well over here. And we can also specify environment variable that will be within the scope of your pod. So for that, you can use env, okay, and hyphen, because this is also a list. You can have multiple environment variables. So give it a name, and let's give the name first name and then a value. So name and value, and it is also a key value pair. Give this a name, give any name, let's say Piyush. Okay. Now this is how we'll use the environment variable. Okay, first let's see and test this thing. So I've created the file. So kubectl create -f and then pod.yaml. Okay, it says it's been created. Get pod. Okay, because we are not doing anything inside the pod, we are just using the busybox image. That is why it is crash loop back, because it actually is the type of image that does a specific purpose, that run a task and then it exits. So that is why it is not showing anything. So maybe we'll add few more details later on. Okay, so we'll leave it to that for now, and let's delete this pod. Okay, and let's proceed further with the multiple containers. Like we'll specify the init containers. So at the same level of container, we specify init container with C as capital. So init containers, it is again a list, as you can have multiple init containers. So let's initialize our first init container and give it a name. Call it init my service. Okay. And then inside that, again, we're gonna use the busybox image version 1.28. And then we'll use something called as command and argument. Let's see how it works. Okay, so command is the command that you have to pass to your container. Okay, so run this command, execute this command. So this could be a simple shell command. This could be a simple Unix command, right? So for that, you use the format as sh and then comma -c, because you will be passing the command. That is why you are appending it with C. And this is the format. You put that in square brackets. Okay, and then sh-c. So you are separating the command with the comma, and both of those will be inside single quotes, right? So this is the command, and now you have to pass certain arguments to that command, right? So that arguments will go over here in the argument section, right? And it uses the same format. So now we'll run a command. So let's say this is the init container that is dependent on the service to be created. Okay, so if we remember the service video that we have looked earlier, in that when you expose a service, your service would be listening on that particular FQDN. So your service dot namespace name dot cluster dot local and something like that, right? So what we'll do is we'll do an nslookup command, and nslookup command will only work when the service is available and exposed, right? So for that, let's write the command over here in the single quotes again. So I'm gonna do until ns lookup, okay, and my service, because this is the service that we'll be creating, dot default dot svc dot cluster dot local, where default is the namespace name. Okay, so it says until this command returns the result, okay, to something. So let's say do echo waiting for service to be up, okay, and then colon, because with colon we are separating the command, and do waiting service to be up, and then sleep for 2 seconds, and then done. After done, you add the single quote. Over here we don't have to really write the quotes. Okay. So done you have to specify because we are using an until loop. So it will work until this and then it will break the loop once it is able to get the result from NS lookup. Okay, so this is the command that we have specified. Now let's add the command in the main container, else it will fail. Right? So we'll go over there. Let's use command. Okay, and you can also combine the command and arguments together. I will show you how we can do that. So over here, let's do sh comma, and then we have -c. Okay, the same way that we have specified the earlier command. Okay, we don't need to give the brackets. We are already inside the bracket. And then comma the argument. So the argument is, let's say, echo. The app is running and we'll add the logical and sleep 3600. So it will sleep for 3600. That means the pod will keep on running for the next 3600 seconds, right? So that it will not exit or it will not go in crash loop. So that's what we have added. So you see over here, we have separated the commands and arguments. And over here, we have placed that in the single line. So that's both are one and the same thing. It just over here, we are passing the arguments to the command with a separate line. Okay, so now our YAML is completed. Let's apply these changes. So kubectl create -f pod. Okay, it says there is an error at line 18. I might have made a mistake. Let's see. 18. Okay, over here. This is probably due to I might have made a mistake over here somewhere around these lines, line 18 or line 19. Although it is showing the error in line 18, but it could be like one or two line above and below. So let's have a look at this. Okay, I guess this is the reason. So I have an extra single quote over here. So it should be within the single quotes, but the entire line. So it starts from here and then it should end after the done. Okay, now let's try this again. Okay, now it says the pod is created. So let's have a look the status. Okay, so if you see now, it says, let me clear the screen and show this again. So it says now ready is 0 out of 1. That means one pod is not ready. And it says init 0 out of 1. That means the init containers that it has, only 0 is available out of 1 init containers. So it is not running. It is stuck in initialization state. Let's do a describe on this pod. Describe pod my app. Okay, so it says over here, let me drag it over here. Okay, so it says successfully assigned this to the cluster, and then it says the image already present on the system, else it would have pulled it, and then it created the init my service container, started the container. Okay, this is the init container, but again, it's stuck in the initialization state because it is waiting for the service to be provisioned first. Okay, and if we go up, so here's here's the status. It says reason of the main pod, the main application pod to be stuck is pod initialization. And here's the command that it ran, sh-c echo, and this is inside the args or inside the command that we have specified. Then let's see. Okay, so this was the arg of the other command inside the init container. Okay, it says it is running. That means the init container is running, but it is not yet completed because it is waiting for a condition to be satisfied, right? And the status is pending for the application pod. And yep, here it is. Now, if you want to see the logs, you can check kubectl logs my pod, my app. Okay, so here is the log. Now, currently we only have one init container. If it would have multiple init containers, then you can also pass the value of that particular container as -c. And let's say the name of the container, let's say this one, okay? my app container is the application container, and init container is the init service. So let's give this a name. Okay, now this is the logs from the init container. Okay, it is trying to do ns lookup on the host name on the fqdn, and it is throwing the message that waiting for the service to be up, cannot resolve this service, which is my service default svc local and so on. And it is keep on doing that after every 2 seconds because we have added sleep 2 in the command as well, right? So this is what it is doing. Now let's do one thing. Let's create a deployment. kubectl create deploy, and let's give this a name, nginx deploy, using the image nginx and port 80. Okay, so deployment is created, get deploy. It is up and pods are up as well. It has one single replica. Now the next is we have to expose this. Currently, if you see the status, it is still stuck in init. This is the my app pod, and it is stuck in init container stage. It is stuck in initialization, and that is why the main application container is not ready. So let's expose the service, and this is looking for the service. Let's see which one, my service, right, in the default namespace. So kubectl expose deploy, and let's give this a name, my service. This should be the name. That this is what the pod is looking for. Okay, I guess the syntax should be deploy and then the name of the deployment to which the service will be exposed to, right? So the name is nginx deploy hyphen name is my service, and let's expose this on port 80. Okay, exposed. Now if we do k get pods, it is still stuck in init, but if you wait for some time, now you see it says pod is now initializing. That means the init container has completed, and now the my app container is up and running. So let's see it again. You see my app is now up and running because the service is now exposed. Now we can do ns lookup on the service name because it is now provisioned. So I hope this would have made sense now. So first it tried to initialize the container, the init container. Init container did it work. Init container actually did the ns lookup. So if you see the command over here, init container did the ns lookup on the service host name, and until it gets the response, it keeps on trying after every 2 seconds, right? And it keeps on printing this message, waiting for the service to be up, waiting for the service to be up. And as soon as the service was up, as soon as it got the response from the service, it actually completed the init container and it actually initialized the pod. So the main application pod is now up and running. If we want to check the application logs of init container, so let's have a look. So this is the init container logs command. So now you see, now it is getting the response back. My service.default.svc. So here is its respective IP. And after that, it stopped printing that message because after that init container job has been done. It got completed. So that is why it stopped printing the messages after that. Now, if we do kubectl get pod, and if you remember, we used an environment variable. So if we do, let's see if it has print env. So k exec hyphen it hyphen. So you remember how we used sh command to sh into the server, because we at that time we opened the shell terminal for that container, right? We actually did the ssh into the container, or we opened a shell terminal into the container, right? But we can run any arbitrary inline command as well in place of sh. So for example, let's say print env, which should print all the environment variables inside the container. So if you see all the environment variables, and let's see if we have our variable which we created, here it is, first name, right? So the environment variable that we set, and rest of the environment variable is the default variables that it set. It take it from the control plane and set it accordingly, and from the deployment. And this one is what we set. It is our own custom variable. So in place of print env, if we can do sh, okay, we have now entered inside the container. And now we can actually enter not just one container. It currently defaulted to my app container, but we can enter inside the init container as well for debugging purpose with -c and that syntax that we saw. So now we are inside the container. Let's do an echo on first name, the variable that we set. Okay, we see that environment variable has been set. So I guess that's what we wanted to check. And the way we have created a single container over here, single init container here, we can have multiple init containers for multiple reasons. So let's copy this and let's create one more. All right. So now over here, and we'll make some changes. So because this is a list, right, it goes like this with the hyphen sign. So we have one init service and then let's call it mydb and use the same image, but instead of my service, we call it mydb. We'll create another service for that and it will basically do the same thing. Let's save this file and apply this change. kubectl apply -f pod.yaml. Okay, it says pod update may not add or remove containers. Pod my app is invalid. Okay, so you cannot, like, we got to know one thing, that we cannot really add or remove the init containers once it is created. So let's do one thing. Let's check the status. Okay, it's still running. So let's delete this, delete pod my app. Okay, and let's apply the changes again. Let's create a new one. Now we shouldn't have that pod running. We have the other nginx deploy, but that's okay. Okay, now let's apply this again. Okay, pod created, get pod, and now it says it has initialized one init container, but the second one has not been done because second one is looking for a different service which has not been yet created, and that is why the pod is not initialized yet. So we got to know one more thing, that a pod, the main application pod, for that to be up and running, all the init containers inside that pod has to be initialized first, has to be completed first, right? So now, because this is stuck in init 1 of 2, that means the first one has already been completed. We already have the service for that. We'll create one more deployment and service for the other container, and let's see how it changes the status. So if we do kubectl, let's use the command again, the create deployment command. Okay, and now this time let's use a Redis image on, and let's call it, okay, let's use the same name, mydb. Okay, and let's use the expose command to create the service in front of this. Okay, and the name has to be mydb because this is what our YAML is looking for, and the deployment name was also mydb. Because these are different objects, one is deployment, another one is service, we can use the same name. And okay, it's exposed. Okay, that svc. So we have two services, mydb and my service. Now let's see get pod, and still one of two. So let's wait for some time. Okay, give it some time and it should initialize it. If you don't want to keep entering the command again and again, you can do -w to watch. As soon as the status is changed, it will show the changes. So now our application is running. All the init pod have been completed, has been initialized because our service are up and running. Right? So you can check the status, you can do the describe, you can exec into the container, and you can basically do all those things. So like always, I have kept a small assignment for you in the GitHub repository for day 11 folder to practice multi-container pods. And I hope you will be able to do that. But if you face any issues, we have our Discord server where you can always ask for help and try to help others as well. This is a community effort. So we grow by helping each other. That's what we do as part of the community. I hope you take full benefit of it. So that's all about of this video. I hope you have found it valuable and you have learned something out of it. If you did, please try to complete the comments and like target for this video, and I will see you tomorrow with the next video. The next video we'll be looking into daemon sets and cron jobs and jobs. It is another type of resource in Kubernetes. So we'll have a look at that and then we'll move forward from there. So yeah, thank you so much and I will see you then. Thank you.